create and configure VMFS data stores. All right, so I promised you that this would be the second half of that last nugget's introduction to storage. And whereas in the last nugget we talked about creating those storage connections, this time we're going to spend our time working on the data stores themselves and how to create them and work with them and just manage all of the elements of those data stores. Now, VMFS and NFS as data stores are some interesting, they're very different than what you may be used to in the NTFS file system if you've been working with Windows for any period of time. NFS it's a Linux-based data store, and it has some capabilities, but really it's defined or designed to be used as a data store for various purposes. And I think I mentioned in the last nugget that a lot of organizations use NFS data stores for the purposes of storing their ISO files, and occasionally in a virtual machine or two if you've got some particularly fast NFS storage. Now, the VMFS file system is designed for use for a relatively small number of extremely large files and has built-in control and built-in support for multiple host access, and so that multiple ESX hosts can access a VMFS data store at the same time. Now, this is somewhat different than NTFS in, for example, Windows 2008 and 2008 R2, whereas even with Windows clustering turned on, only one host can still talk to a single file at the same time. So VMFS very specifically designed a file system for use in virtual environments with, again, those very large files. Not a lot of them, but lots of very large multi-gigabyte, sometimes even as much as a terabyte or percentages of a terabyte size. Now, even with the improvements to VMFS, right, even the fact that VMFS is designed for these very large files and a small number of them, there are still some limitations that come into play whenever you've got extremely large data stores. And this holds true whether it's VMFS, NFS, or even NTFS. And a lot of this has to do with just simply the processes that you would have to go through in order to bring back or resurrect that data store, that volume, if you should experience some sort of volume-centric problem. And so one of the primary use cases that people use today, perhaps different than if the fact that they've actually hit one of the maximums. So not only have you hit the maximum allowable storage space for VMFS, but even below that, you may actually not want to just create lots or a small number of very large VMFS data stores. Backing up those data stores can be challenging. Restoring them or recovering them in the case of an entire volume situation can be challenging as well. And so creating smaller numbers of data stores that are tuned to the size that fits both your ability or your need to put lots of virtual machines on them, and yet is still small enough that restoring them, recovering them is not going to be a very big problem. This is the trade-off that you have to make whenever you're determining whether or not you want to create a large number of smaller stores or a small number of larger stores. Now, all of this aside, what you're interested in today really is in understanding how you will actually go about creating and working with those data stores. And that's really the topic here for the bottom section where we're going to interact with our ESX environment. Now, we're going to create a VMFS data store out of the iSCSI connection that we created in that last nugget. And then with that, we're going to take a look at it and all the different management things that you have to be aware of, not only just browsing the data store, but also adjusting some of its configurations to include things like storage capabilities and user-defined storage capabilities and storage I/O control. These are new things that have been brought about in vSphere 5 that I think you'll really appreciate because they add in some much needed capabilities that make the working with storage a little bit easier. I'm going to show you how to extend a VMFS data store, and then I'm going to conclude by taking that existing data store that currently only has a single path connected to it, and then add additional paths for the purposes of high availability and potentially load balancing as well. So what this does is this completes the whole story of storage and then presents you with the ability to begin hosting virtual machines. So let me actually minimize this, and you'll see we're back here at vc.company.pri. This is our vCenter server. And as of the last nugget, I have that local storage here. This is data store 1. This is the local directly attached storage to the ESX host. And then I also have that NFS mount that we created here earlier. This NFS mount is already been, a data store has already been created for this NFS mount. If I right click and choose, I can actually browse that data store and see all the contents of the files that are in that data store. Now, at the conclusion of that last nugget, we actually went through the process of setting up the networking for this storage, and then we also set up the iSCSI stuff associated with the storage, and we have one connected target and one path to that target that are available. The step that we did not complete with is actually creating the data store out of that LUN that's now been exposed and plugged into the ESX server. Let me go ahead and do that now. Now, if I click the Add Storage button here, earlier we worked with the network file system, but what we want to do now is actually work by creating a disk/LUN storage type, which is associated with iSCSI. I click the next button here, and if I see that disk in my list of available disks, which I do here, then I know that I've done everything correctly. Let me go ahead and click Next once again, and we'll see that we have two different options here for the type of file system we want. Now, VMFS 5 has additional capabilities over what we got with VMFS 3, such as 2 terabyte or greater support. However, VMFS 5 is not supported by hosts with ESX that are older than version 5.0. The real thing that you should be aware of here is that you want to be on VMFS 5, but don't begin creating these LUNs until you have enough hosts that are at version 5.0 or greater so that they can support actually pulling this LUN onto those hosts. Now, these hosts are both at version 5, so I can create this LUN this data store as VMFS version 5. I'm going to create a partition here. You can see it's not quite 200 gigabytes in size. And then I need to enter a data store name. I'll call this VM Data Store 1. And choose the next button here. And I can format it to the maximum available space if I want, or I can choose a custom space setting if I want. In my case, I'm going to choose actually just 100 gigabytes of this space, because a little later on I want to show you how you can add an extent to extend the data store to take advantage of additional space that may be available to it. Now, if I click the next button here and finally finish, it's going to take a minute or so for it to complete the task here in creating that VMFS data store. Once that data store is created, well, then just like before, I can actually go through and browse that data store for any of the contents inside it. Now, as you can see here, there's nothing to see. We haven't actually added any virtual machines to it. There's nothing on this data store with which to do anything with. I can, just like before, go through here and see some of the information associated with the data store if I want. Now, at this point, I have this data store that I've created. This is shared storage. This is the kind of storage that I'm going to want to put my virtual machines on so that they can support a cluster, so that they can support vMotion and all the fun advanced things that we're going to talk about in nuggets to come. Now, before we get there, however, there are some configurations associated with these data stores that we want to pay particular attention to. The first of which is the assignment of this user-defined storage capability. And as you can see down here, in version 5, we now have the ability to identify what these storage capabilities are, some of which are going to be presented to us from the system itself, others of which are going to be user-defined, or the ones that we actually create. Now, if I go back here and assign a user-defined storage capability, this is a relatively subjective task. Here, I can actually create new storage capabilities if I want and name them whatever I want and give them a description. In fact, I actually created already one here to switch the storage capability from none to just plain awesome if I want. Or I can create additional storage capabilities. Not that great. Don't use unless you have to. So all of these are storage capabilities that I can create and then assign to this piece of storage. Now, why would I do this? By creating these user-defined storage capabilities, later on when I'm looking at my inventory from different views, I can then identify what my storage is based off of identifiers that I have selected for that storage. So this gives me the ability later on when I'm taking a look at, for example, data stores and data store clusters, at all of the different types of storage that I might have available to me, and additionally all of the different types of configurations that that storage may have. Take a look down here and you can see these are those configurations, and here are some of the storage capabilities that are associated to that storage eventually once they finally update. Now again, these are designed to provide an assist to you for as you're going about constructing that environment, to give you multiple different views with which to identify what the storage capabilities and what the different characteristics are of all the storage that makes up your environment. But applying these labels is only so useful. Right? One of the things that was definitely requested between the release of ESX version 4 and now here in ESX version 5 is more hard level control, more real controls that can be put on storage, because storage has been found to be a significant bottleneck for the performance of virtual machines. One of the tools that have been added here in ESX version 5 and vCenter version 5 is this notion of storage I/O control. I've clicked Properties here for VM Data Store 1, and I'm taking a look here at this Storage I/O Control node. Now, if I click the Enabled button here, and then click the Advanced button, and click through the little warning here, you'll see that Storage I/O Control is currently set to 30 milliseconds. What this identifies is whether or not this storage is considered to be congested or not. And Storage I/O Control actually works with another technology, Storage DRS, that we'll talk about a little bit later, to identify when I have too many virtual machines that are vying for control or access to this available storage. When the amount of time it takes to get something accomplished, so some sort of change on that storage accomplished, increases above a certain threshold, well, then Storage DRS leaps into play if it's configured appropriately in order to be able to rebalance those storage connections appropriately across what you have. So enabling Storage I/O Control, as you can see here, is kind of the first step in that process. I mainly want to introduce it here because Storage I/O Control is one of the settings that you will see when you first create that data store. Now, one of the other things I talked about that I wanted to introduce to you here in this nugget is the notion of expanding those data stores when you begin to run out of space. Now, when we created this VM Data Store 1, you remember how we created it with 100 gigabytes of storage from the LUN that was presented to it. We've created essentially a single 100 gigabyte extent that is essentially the composition of this VM data store. At some point, you're eventually going to begin to run out of disk space on this particular data store. And as you can see here, I have, of this 100 gigabytes here in the partition, the device is currently making available to me 195.31 gigs. And so one of the ways that I can go about actually adding additional storage, kind of almost in the same way that I would do within the Windows operating system, is to extend this VMFS volume to add the additional storage that's available. I can do so by clicking the Increase button here. Now, what I'm doing here is I'm increasing the data store capacity across the LUN that's been exposed to that data store. I will have, in a production environment, I will have already needed to expand the volume prior to doing this, and that's a task that will be done at the storage area network side. Once that volume's been extended, then I actually have to come here into the operating system and then extend it here to make the volume bigger, or to make the data store bigger. Now, I'm going to select this disk device that we used before, and then from it, what I'm going to do is actually make use of the existing free space as a second extent that's attached into this data store. I'm going to click the next button here. I'm going to make it the maximum available space associated with this. And the next button again, and finally finish. And after a minute or so, you'll see that what we've done is we've extended this data store to a much larger capacity here, 195.25 gigabytes. And so what I've done is now I've taken the existing space that I've exposed to this LUN and then filled it up with the rest of the data store. This provides me more space with which to work with my virtual machines. So closing down here, we mentioned that, or we talked about how this nugget, it's very important for us to understand all of the different functionality associated with these VMFS data stores. And I mentioned to you that in creating this initial connection to a VMFS data store, what we did was set up a single network card that plugs into a single vSwitch that ultimately creates that single path between server and storage. Now, if you're like me, anytime you talk about anything being a single, I always think of point of failure to go with that. And so the next and final topic that we want to talk about for this nugget is the process of creating and managing multiple paths for these VMFS data stores. And just like before, I want to focus in on the iSCSIness of this because that's the type of storage that I have available to me. I want to do that by going back, first of all, here to the networking node. Now, you remember down here at the bottom when we were working with vSwitch 1, and I've got this VM kernel port here, and I've set it for storage, and I've given it an IP address here. Well, what I want to do is create another VM kernel port and associate that with another IP address. In this case, it'll be 206. Then I want to assign this 206 IP address to associate itself with another physical adapter. Now what that does is that essentially chains the physical adapter to the VM kernel port. And on the other side, that physical adapter ultimately to the storage and the storage processor at the storage area network. Let's go ahead and do that so we can take a look at how this might work. If I choose Properties here, and then I go to Network Adapters, and I click the Add button here, I'm going to add in VMNIC2 because I want to add in the secondary NIC. If I choose the Next button here, I want to add this to the list of active adapters for this vSwitch, and Finish. Now that I've done this, as you can see here, I've got this second network adapter here on the right-hand side, but I'm not done yet because I need to associate this physical adapter with another VM kernel port. This has to be a one-to-one mapping for the purposes of iSCSI. If I click Properties here, and then what I want to do is create another storage VM kernel port. I'm going to do so here by clicking VM kernel, Next, and I'm going to call this Storage 2. Storage 2. I'm not going to run any of those other features over this. This is just for the purposes of storage. Click Next, and then assign this the IP address that I mentioned just a minute ago, 192.168.0.206, with that 24-bit subnet mask and the original default gateway. Choose Next and Finish. And as you can see now, what I've created are two different adapters that are plugging in to two different ports. Now if you'll notice, I'm going to go back here to Storage Adapters here and take a look at the iSCSI software adapter and view properties of VMHBA33. Remember when we were working back with networking configuration and I told you to go ahead and ignore the different ports that were available, the different paths that were available? Well, you'll notice now that the path shows least active, but my port group policy is actually set to non-compliant. This is an important characteristic here because what I need to do in addition to setting up that one-to-one linkage is go one step further with the networking here in vSwitch 1. I have the first half of a one-to-one linkage between my two VM kernel ports and my physical adapters. But the one thing I want you to notice here, if I take a look at storage and then edit, and then NIC teaming, is that both of these adapters are currently considered active adapters for both of those VM kernel ports. iSCSI, in its multipathing configuration, does not like to have multiple adapters that connect into a single IP address. And so the only way I can really make this work is to override the switch failover order and move the other adapter down into unused adapters. I need to do this here for storage 2, and I need to do it again here for storage 1. Click Edit. Go back to NIC teaming, override the switch failover order, and then move NIC 2 down into unused adapters. If I click the OK button here, you'll notice I have an error message that warns me that this is currently bound to an iSCSI initiator, and I'm okay with that. We'll unbind it and rebind it later. But not much really changes here. The way that this screen looks hasn't evolved much. But what I have done is create a complete one-to-one linkage between storage 2 as a VM kernel port and specifically the physical adapter VMNIC2. I've done the same thing here for the original VM kernel port and VMNIC1. The last step that's required is back here under storage adapters and then back to the iSCSI software adapter because I need to adjust the network configuration here for how I've bound these different VM kernel ports in the last step to the iSCSI initiator itself. Let me go back here and click Add, and you can see that I have both VMK1, the storage port group, and then VMK2, the storage 2 port group, that are available to me for binding to this VM kernel network. If I click OK here, and I click OK again, I have now bound both of these two storage ports to the iSCSI initiator for the purposes of running iSCSI traffic across this connection. If I click Close here, and then rescan the adapter, and then click Properties, you'll notice that I have the ability to actually take a look at the path information for the connection of this iSCSI software adapter all the way back to its storage. Notice here that I have two connected targets, one device, and now two complete independent paths to those targets. Let's click Properties again and view network configuration. And you can see that my path status here is active for both of these two ports. I now have successfully created a failover capable and load balanced connection between my iSCSI storage and my server. This is a good thing. The last thing I want you to take a look at here is once we have all of this path information set up, I can go back to my storage here and take a look at the data stores that I was working with before. Now remember, I have multiple paths now to this data store. This is a good thing. I have 2 total paths, none of which are broken. But there is a chance here for me to manage the paths by clicking Manage Paths, and also the path policy associated with those 2 paths. There are, by default, a fixed path policy that's set for this connection. But what I may want to use is instead the round-robin path policy for enabling true load balancing across both of these 2 connections. Enabling round-robin is necessary if I want load balancing because the fixed path policy will only send data down the currently active path. Setting round robin here, clicking close and clicking close again, completes the process of setting up a load balanced and failover capable path configuration for iSCSI. Now what have we talked about in this nugget? What we've done is really completed the whole storage conversation as it relates to VMFS data stores. We talked about VMFS and NFS data store properties and how they're somewhat different than the NTFS data stores and volumes that you've been working with in the Windows world. And we also talked a little bit about some of the use cases for creating multiple VMFS and NFS data stores. We had the opportunity to work with some data stores, not only creating them, but managing them, and including some of the new capabilities like user-defined storage capabilities and storage I/O control. We extended that VMFS data store, and then we also made it redundant so that we can support the loss of any type of component across the entire path from servers to storage. I hope this has been informative for you, and I'd like to thank you for viewing.